All right, everyone. I hope you're having a good week. I hope you're getting some rest and being able to see family and friends. All I want to do is just kind of recap what we would have covered on Tuesday's class. So I believe we talked about how to name place values. So to the left of the decimal, we have ones, tens, and hundreds. To the right of the decimal, we have tenths and hundredths, and then it would be thousandths. So the TH is an indicator that we're to the right of the decimal. So like we said with Engage New York, if we want to represent 3 ones and 7 tenths, we would have to divide that fourth box into tenths. And so if we divide one box into tenths, everything gets divided up into tenths. I believe I've said that before. So in order to shade in 3 ones and 7 tenths, we would shade in these 3 boxes, and then 7 of the strips. 1, 2, 3, 4, 5, 6, 7. Just do a big shade. 7 of the strips. Right? And then we would shade in these 3. So it says write the following in decimal form. So that would be 3 ones. A decimal means and. 7 tenths. And then they said as a mixed number. So that would be 3 and 7 tenths. All right, just showing you like the grid that they often use. Same with marking things in hundredths. It says find the equivalent fraction using multiplication or division and shade the area models to show the equivalency and record as a decimal. So this says we start off with 3 tenths. All right. So 3 tenths would be these 3 bars. Right? But if we gridded this off into hundredths, do you see we would still have the 3 vertical bars? But that would be 30 hundredths. So if we multiply the bottom by 10, we multiply the top by 10, and that's how we get our 31 hundredths. So I just wanted to show you quickly that they will talk about tenths with the area model, and they'll talk about hundredths with the area model. So nothing like too crazy exciting with that. Let's flip. I wanted to show you the expanded form. Something like this is on the final, so let's look at this a little bit. So like I've always said that Engage New York loves expanded form, and they will continue with expanded form in fraction notation and in decimal notation. So I really think it's quite clever how they continue with expanded notation. So we've got, there's our 15, and then we've got 4 tenths, and then 3 of these 100ths. And then they also can write this as 4 tenths and 3 100ths. So expanded form can be used for really big numbers and also the smaller numbers. So that is something that we want to be sure we're comfortable with for the final. So this would be 2 times 10 plus 1 times 1 plus, and this would be 4 times 1 tenths. If we want to do 21.4. And then it also would be 2 times 10 plus this 1 times 1 plus this 4 times a tenth. So we can do expanded form in fraction notation and in decimal notation. I also like this problem because not a lot of us think in terms of tenths and hundredths as 15 hundredths. So do you see that this number starts off with 1 tenths and 5 hundredths. But in a tenth, I want you to see how they break this down because we're in base 10. If I get rid of this manipulative, I would make 10 of the next manipulatives. It's interesting how this is the same concept, right? If I had a long here and I broke down the long, I would make it into 10 singles, right? But it's the same thing for a tenth. If I break down a tenth, it gives me 10 hundredths. So 1/10 plus 5 hundredths is 15 hundredths. So it's an interesting way to look at this problem. 1/10 and 5 hundredths is 15 hundredths. I just think it's an interesting way to look at this. So this is 2/10 and 1/100. Well, if we break down a manipulative in base 10, we get 10 of the smaller manipulative. So 2/10 plus 1/100 is 21 hundredths, or 0.21. I think that's very clever. I love that. I love this kind of engaged New York concept with this really neat number sense. And then, of course, we're going to look at converting back and forth. Like they understand these equivalencies. If you multiply the bottom by 10, you multiply the top by 10. And this is going to help us add fractions to get common denominators. And this also shows us how to add in decimal form. Anyway, I believe we talked about this. I always said that I'd rather multiply with decimals. Someone in class, I think, said they'd rather multiply fractions. It's quite lengthy to multiply those. You can use the standard algorithm or any of these algorithms we've dealt with the decimal form. But let's just talk about zeros. So if you have a zero that's in between two non-zero digits, that zero is necessary. This zero that comes before the decimal, where there's not another, remember it has to be stuck between two non-zero digits, this isn't necessary. So they have a nice lesson in Engaged New York that talks about where the zero is necessary or not. Like this isn't necessary, but this is because it's stuck between two non-zero digits. This is necessary because it's stuck between two non-zero digits. This is not necessary because it's not in between two non-zero digits. Now these are numbers, when we talk about necessary zeros, these are the zeros that come after the decimal, right? But obviously we would need the zeros for that. If they come before the decimal, right? We obviously need those zeros. So the only time we don't need the zero if it comes before the decimal, if there's not another digit that precedes it. So that's a little lesson in Engaged New York too about when the zero is optional. I believe we did this page and we talked about these fractions that students just know. They know 1/4 is a quarter, 0.25. And it's, I think, much easier to organize decimals from smallest to largest than it is to organize fractions from smallest to largest. So that is a skill that is taught in Engaged New York. To translate decimals into fractions, it's just exactly how you read it. This is 1/10. So that's what it would look like as a fraction. It goes tenths, hundredths, thousandths. So this is 7 thousandths. Now these might be something that you're not accustomed to, being able to go back and forth between a repeating decimal and its equivalent rational number. So this is something that is taught in 6th grade. And so I just thought I would show it to you to see if you remember it, and if not, it's a good skill to understand. So if we're trying to find the fraction that's equal to 0.3 repeat, I'm sure you guys remember it, that know that it's a third. But what you do is you set x equal to that repeating repeating decimal. Now I'll just write a couple iterations out so we understand that the 3 is what is repeating. Now what you want to do is you want to see how many digits are repeating. So there's 1 digit that's repeating. So we're going to multiply that x by the same number of zeros as the number that's repeating. So since 1 digit is repeating, we're going to multiply 10 by 1 with 1 0. Now I'm hoping you'll see that if we multiply this, what you do to one side, you got to do the other. If we multiply this by 10, it's just going to be 3 with the repeat. Right? All of these are just going to increase by 1 place value. So it would be 3.3333. So if we multiply the left-hand side by 10, we got to multiply the right-hand side by 10. And then I want you to see something. When we subtract the top equation from the bottom equation, this side becomes 9x. And when we subtract the top equation from the bottom equation over here, do you see that the repeat cancels out and we just have 3? And then to solve for x, we're going to divide both sides by 9. And this is where we get our 1/3. Now let's try another one. Let's just try the 0.18 repeat. Well, here, you know what? Let's try 0.6, and then we'll come to do this. So I'm hoping we all know that that's 2/3. All right, but let's just see where we get the 2/3 from. So we're going to set x equal to 0.6 repeat. So that one number is the repeater. So we'll multiply the left-hand side by a 1 with 1 0. And we'll multiply this side also by a 10. Right? If you're not sure, like, how did she get that? If you look at my calculator, if I just have 0.66666 and I multiply it by 10, do you see that decimal? I know we're not supposed to say it just shifts one place to the right, but all these numbers really shift one place to the other side of the decimal. They all increase by a factor of 10. All right, and then we subtract. So the left-hand side will give us 9x. If I take 6.6 repeat and I take away the repeat, do you see we'll just have 6 left? And then to solve for x, we divide both sides by 9. And if we simplify that down, that gives us 2/3. So let's try one where we have 2 decimals, or 2 numbers that are repeating. So let's let x equal the 0.18, 18, 18, dot, 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 dot. So now we have 2 digits that are repeating. So we're going to multiply by a 1 with 2 zeros on the left-hand side. And if I multiply this by 100, I'll get 18. And then the 18, 18, 18, dot, 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 dot. So now we subtract. So 100x minus x gives you 99x. And then do you see when we subtract these, 18.181818 minus the 18181818, the 18 just falls out. And then to solve for x, we'll divide both sides by 99. And this looks like it's going to give us 2/11. Let's check that. Let's put 2/11 in our calculator. And then change it. There you go. There's the 0.1818181818. Let's try one more. Let's try one more just to make sure. So if you flip the page, let's try another one where it's a repeat. How about we do, how about let's do 0.27 repeat. So why don't you pause the video and then just see how it works out for you. So we'll let x equal 0.27, 27, 27, and then it's 2 digits, so I'm going to multiply by 1 with 2 zeros. And if I multiply that by 100, what you do to one side, you've got to do the other. I mean, you can do this on your calculator. See? But everything's going to increase by a factor of 100. So this is going to go two spots here. The decimal really is not what's moving, it's this moves. It's going to go tens to the hundreds. The 7 is going to go from the tenths to the 1 spot, and then everything's going to get shifted. So it's 27, and then 27, 27, 27. Okay, so if I have 100x and I take away x, that gives me 99. And then the repeat goes away, and I'll be left with 27. And if I divide both sides by 99, x will equal 27 over 99. And I believe if we simplify that down, that's going to give us 3 over 11. Let's check. 0.27, 27, 27, 27. And then the last little bit that is on the test is something like multiplying a fraction by a decimal. And of course, Engaged New York loves their area model. So we want to take 1/10 of 1 4/10. So this is your 1. And then 4, so this whole thing is my 1, right? And then 4/10 would be 4 of these, like this. Right? So I'd have this whole thing shaded, and then that much of the second piece. So if I want to take 1/10 of that, it would be this strip right here. Right? But we'd stop right there. So what do we have left? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 tenths. Now let's try this one up here. So we have 3/10, 4/10 by 3/10. All right. So let's start off with 4/10. That would be right here. And then I only want to take 3/10. So that would go this direction. Right? And so this right here would be the common box. That would be the area. It's 4/10 right here by 3/10, which would be right here. So this is the area that we're interested in. And you can see out of the whole box, which has been divided up into 100 parts, we have 12 of them, or 0.12. Same with this, like this has been divided up into, I believe I said tenths, and I really should have said hundredths. This has been divided up into hundredths, so each of these little boxes is hundredths. I think I said tenths and I meant hundredths. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 boxes, and each of those are hundredths. So that would be 14 hundredths. All right, last one. So we're going to take 6/10 of 1 and 7/10. All right, so this is 1. This is 1 full pan of brownies. And then we're going to take a 7/10 of this one. 1, 2, 3, 4, 5, 6, 7. So 7 strips right here. So if I had a highlighter, I would highlight this entire pan of brownies, and then I would highlight this part. And then when we were doing this before, right, we would cross this off. I don't want that. That's not part of my problem. And now I want to take 6/10 of it. So 1, 2, 3, 4, 5, 6, right? And this is where 1, 2, 3, 4, 5, 6. I would shade in my area of interest. So right here is my product. So these are all 100ths, right? Each of these little boxes is considered a 100ths. So we can count these up. We've got 10, 20, 30, 40, 50, 60 hundredths here. So this is 60 hundredths. And then here, let's add these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And looks like then another 21. So we're going to have 42 hundredths. So we'll have 60 hundredths plus 42 hundredths. So that's going to give us 102 hundredths. Or we can get a full pan of brownies, and then we have 2 hundredths left. So I really like how they are showing us how to do these with a proper fraction and a decimal, and they're just using the area model to figure out these products. And I just think Engaged New York is so clever that way. So anyway, I hope you are all having a great break. That's it. Don't forget you have an Oh Wow that's due when we see each other again on Thursday. And then taking these notes and handing them in will also count towards an Oh Wow. And we will review for the test when we see each other on Thursday. Okay, so have a great rest of your break, and I will see you on Thursday. I believe it's November 30th. Before I leave, let's just make sure that's correct. So you're going to hand in a wow, and you're going to hand in these notes on November 30th, and then coming to class will also be an oh wow to review for your test. All right, have a great week, everyone.